In this video, I'm going to explain conditional indexing. This means indexing can be done with a conditional statement. X is the following vector, -1, 9, 4, and so on. If you want to extract even-numbered elements, x of if x mod 2 is equal to 0, then here it is. Look another example. You can use a separate variable for indexing. Let's say k is 1 through 8. If you want to extract elements in even-numbered position or even-numbered indices, then x of if k mod 2 is equal to 0. Then there you go. Now, let's look at an audio signal. X is a tone of 100 Hz for 100 milliseconds. A very short signal. I want to show you the details of the waveform. So you see x, a sinusoid. Now, define y as x of x greater than 0. Then, now you see the positive portions of the waveform extracted. Let's try a fun example. I want to apply a peak clipping at 0.5. Then you can write that anything from x above 0.5 shall be 0.5. There you go. See how the waveform changes. Do the same for the negative. Not too bad, huh? Now, let's look at examples of conditional indexing for matrix. First, define X as a 6x4 matrix. Double-click the variable to see the values. First, I want to extract the second column, then X of colon, comma, 2. Next, I want to extract even-numbered rows for the second column, then X of 1 through n mod 2 is equal to 0, comma, 2. There you go. As a final note, if you use conditional indexing with a replicator, then your AUX expression can be really powerful. If used well, you can reduce the coding significantly and improve the readability of your code.